Good morning, good afternoon, good evening, wherever you are listening from me. This is Mr. Katenda. Okay, so I want us today to simplify organic chemistry. So I want us to simplify again organic chemistry from fractional distillation of crude oils to alkanes, then from alkanes to alkenes, then from alkenes to alcohols, then to carboxylic acids, to esters, at least up to there, and possibly polymers. Okay, so this is how we are going to do it. So when we have crude oil, we know what crude oil is, or petroleum oil. That is the other name for crude oil. So when we have crude oil, so we are saying crude oil. Okay, so that crude oil, in order for us to obtain saturated hydrocarbons, that is the alkanes. So in order for us to obtain alkanes from crude oil, there is a process which is done there. So from crude oil to alkanes, so we have alkanes. Okay, so those are the alkanes there. We circle them, we put them in a box. Okay, so these alkanes, in order to obtain alkanes from crude oil, the process which is involved there, or the process which is there, is fractional distillation. That is separating of the mixtures of crude oil according to their fractions. That is fractional distillation. So the process here we are saying fractional distillation. Okay, fractional distillation. So fractional distillation, which is the process involved there from crude oil to alkanes. Then what about from alkanes going to alkenes? So before we even go there, these alkanes, we call them saturated hydrocarbons. Why? Because their combining capacity has not been, meaning their combining capacity has been fully used. No wonder we call them saturated hydrocarbons, because they only contain single bonds between carbon to carbon atoms there. Okay, so from alkanes we go to alkenes. So alkenes. Okay, so how do we obtain alkenes from alkanes? So we obtain alkenes from alkanes by the process known as the process known as cracking. So this cracking can be thermal cracking or catalytic cracking. So thermal cracking, that is where heat is used to decompose them in order to form alkenes. Then catalytic cracking, that is where a catalyst is used to break them from alkanes, large molecules of alkanes, into alkenes. Okay, and the other product there will be a small molecule of an alkane. Okay, and now that we have alkenes there, it is possible to obtain alkanes from alkenes. Okay, so it is possible to obtain alkanes from alkenes. So the process there, it is, we know alkenes undergo addition polymerization. So the process here, in order to obtain alkane from alkenes, that is under addition polymerization. That is addition reaction, not polymerization, addition reaction. So that addition reaction, when hydrogen gas is added to an alkene, it will give us an alkane. Okay, so this is the process. This is the process known as hydrogenation, because we are adding hydrogen gas. So we call this process known as hydrogenation. So this hydrogenation is the addition of hydrogen gas to an alkene in order to form an alkane. Okay, of course, with the catalyst involved there, which is the nickel catalyst. Okay, then from alkenes, we can also obtain alcohols. Okay, so we have alcohols or alkanols. That's the other name for alcohols, alkanols. So in order for us to obtain alcohols from alkenes, there is a process known as so it is also addition reaction that alkenes undergo. So when steam, which is water in gaseous state, is added to an alkene, it will form an alcohol. So we call this process known as hydration. So hydration is the addition of water, which is the steam in gaseous state, which is water in gaseous state, addition of steam to an alkene in order to form an alkane. Okay, so hydration, I can even say in brackets addition of H2O. So addition of H2O, which is hydration. Now, the same alcohols here made by hydration of alkenes, they can also be used to produce alkenes. So there is also a process whereby alcohols are used to produce alkenes. So this process is known as hydrolysis. Hydrolysis or hydrolysis. So this hydrolysis, now we are removing the water which was added there. So when the water is removed from an alcohol, which is H2O, then we are getting back to an alkene. So for example, if we have, then we add water, we are going to have ethanol, that is hydration. Then when we have ethanol, we remove water, that is the hydrolysis, we have ethene. So that is those two processes there. And then from alcohol, we can also obtain another compound from an alcohol. So we can obtain a carboxylic acid. So we can obtain a carboxylic acid. So the process there where we obtain a carboxylic acid from an alcohol, we call it oxidation. Yeah, so oxygen atom there is added to an alcohol in order to form a carboxylic acid. Now, this oxygen atom, it comes from an oxidizing agent. So an oxidizing agent, it's a compound or a chemical element which makes it possible for oxidation to take place. That is an oxidizing agent which facilitates oxidation. Okay, so an oxidizing agent there, we are saying it is potassium dichromate. So potassium dichromate or potassium manganate, which is the oxidizing agent there, potassium dichromate or potassium manganate, which is the oxidizing agent. So the oxygen will come from that oxidizing agent in order to form a carboxylic acid. Okay, now there these alcohols, Okay, so when an alcohol and the a carboxylic acid react, they form a new compound. Okay, so when a carboxylic acid and acid react, they form a new compound. So this new compound is known as an ester. An ester. So this process of forming an ester from one alcohol and a carboxylic acid, we call it esterification. Esterification. So when they say what is esterification, it is the process by which alcohols and carboxylic acid reacts in order to form an ester. That is esterification. Now, what is an ester? An ester, a compound formed from the reaction of an alcohol and a carboxylic acid. I remember those old days, they used to say an ester is a sweet smelling compound, which is correct because esters are used in the manufacture of perfumes. Okay, so that's the definition of an ester. And then from what we have there, under, maybe we go a bit back, under the reaction of alkenes, under alkenes there, that is addition reactions, that is where we can also find polymers under alkenes. So when alkenes react together, they form polymers, so which is the process known as addition polymerization. Okay, so these alkenes, when they are added together, they form a polymer. Okay, so we say a polymer, so we can just say, okay, let's just say polymer. So since it is from an alkene, it can be a polyalkene. Okay, so if it is ethene, which is used there to form a polymer, then it will be polyethene. So the process of forming polymers from alkenes is the one we are calling polymerization. So polymerization. Okay, yeah, so then other, maybe we just talk about other reactions of alkenes. Apart from cracking there, we have cracking here. So the other reactions of alkenes, alkenes undergo 3 types of reactions. So the number 1, cracking. Number 2, we have substitution reaction. Number 3, we have we have combustion. So combustion, which is the burning of a substance in air in order to produce carbon dioxide plus water, if it is complete combustion, or if it is incomplete combustion, then it will produce carbon monoxide plus water. So we are saying combustion, the burning of a substance in air to produce carbon dioxide plus water and the energy. So no wonder these alkanes are used as gases. Okay, they produce also energy apart from carbon dioxide and water. Okay, those are the reactions under alkenes. Then alkanes. Then under alkenes, we also, there we only have 2 types of reactions. So number 1, which is combustion. So combustion for alkanes and alkenes is just the same. We produce carbon dioxide plus water in complete combustion, or carbon monoxide plus water in incomplete combustion. Okay, then then the other reaction, I said 2. So the other reaction of alkenes, we have so the other reaction of alkenes, maybe I write them here for easy understanding. So let's say alkanes first. Reactions, number 1, we have said combustion. Here it is. Then number 2, you can say substitution reaction. Substitute is to remove and replace. So even substitution reaction here, one of the hydrogen atoms of an alkane are removed and replaced by an halogen. Okay, so that is a substitution reaction. The halogen is the group, those are group 7 elements. Those are the elements which replace the hydrogen of an alkane. Okay, in order for substitution reaction to happen there. Number 3, it is cracking. So cracking, we said the breaking down of molecules of alkanes in order to form a small molecule of an alkane and an alkene, or sometimes it may not be the small molecule of an alkane. Maybe it may be just the hydrogen and an alkene. Sometimes also it may be a small molecule of an alkane and the hydrogen gas. So that is under cracking. Okay. Then the reactions of alkenes. So reactions of alkenes, there we have reactions of alkenes, we only have 2. Number 1, combustion, which we say is the burning of a substance in air to produce carbon dioxide and water in complete combustion, and the other one for incomplete combustion. So 2, it is the addition reaction. I think we'll end here now. Before we end here, under addition reaction, we have 5 types of reactions here. So we list them. So it is hydrogenation, which is the process used to form alkanes from alkenes. B, halogenation, which is the process of adding molecules of, halogen molecules to alkenes there. Okay, in order to form alloalkanes. So if it is chlorine there, for example, if chlorine molecule is added to ethene, then it will be 1,2 dichloroethane. Okay, then next, C, we have hydrogenation. So hydro there for hydrogen, halogen for halogens, which are group 7 elements. So hydrohalogenation is in the is added to a molecule of an alkene there. Okay, so for example, hydrogen chloride. So it is ethene, then it will be 1,2 dichloroethane. Okay, then next, C, we have hydrohalogenation. So hydro there for hydrogen, halogen for halogens, which are group 7 elements. So hydrohalogenation is in the hydrohalide, which is added to a molecule of an alkene there. Okay, so for example, hydrogen chloride or hydrogen bromide. So those are hydrohalogens. Okay, D, we have addition polymerization. Okay, so that is the fourth one, addition polymerization. That is the fourth one, addition polymerization. Okay, then we can move to the last one. Okay, the last one, which is hydration. Okay, hydration. This is the addition of steam, which is water, to an alcohol in order to an alkene in order to form an alcohol. Okay, so I think we can end here. We have at least simplified organic chemistry here. So the next time we meet, we'll talk about how the the molecular formula and the chemical formulas of these alkanes and the structural formula of alkanes and alkenes are formed. Okay, so that's what we'll discuss next. Okay, thank you for your time. Kindly subscribe to my YouTube channel, which is in Katenda 94277. Katenda 94277 without leaving a space there. Okay, thank you for your time. Let's support one another. Thank you.